This is John. John has epilepsy, a neurological condition that is characterized by recurrent seizures as a result of electrical disturbances in the brain. Epilepsy symptoms include temporary confusion, loss of consciousness or awareness, and uncontrollable jerking movements of the arms and legs. Some of the known causes of epilepsy are genetics, neurological infection, and as a result of head injuries, stroke, and tumors. Yet, several causes are still unknown. John is not alone. He is one in more than 50 million people worldwide who have epilepsy. In fact, in US, it is estimated that 1 in each 26 people has epilepsy. Unfortunately, there is no cure for epilepsy. Consequently, we can only rely on mitigation strategies. In 70% of the cases, the symptoms are under control by taking a combination of different medication. In some of the remaining cases, subjects may qualify for invasive surgery. In those cases, two options are available. On one hand, resection consists in a irreversible cut in the cortex where the seizure onset takes place. On the other hand, a neurostimulation device can be deployed in the cortex. The neurostimulator has the capacity to measure neural activity through electrodes designed to measure differences in the electrical potential, and also it has the capability to discharge electrical stimulus into the cortex. Nowadays there are different neurostimulators approved for medical use. Yet, decisions on how to interact with the brain are still done ad hoc. The so-called responsive neurostimulators gather measurements during a period of time. Then, a combination of classifiers will determine if there is a likelihood of a seizure. Upon the observation of an event, the actuators will deploy a sequence of electrical discharges that has been predefined. Once the neurostimulator is deployed in a subject, they will be under continuous observation. The efficiency of a stimulation strategy is reassessed every couple of months by checking if the total number of seizures has decreased significantly. If not, then the next generally predefined sequence of discharges is adopted. Nonetheless, these predefined sequences of discharges do not take into consideration individual factors such as age and gender, neither the location of a seizure onset nor where the device has been deployed. Altogether, predefined strategies do not consider the specific dynamics of the brain activity nor the response to the discharges towards attaining a desirable goal. As a consequence, we propose that neurostimulators should deploy strategies using closed-loop feedback. As such, they will implement a data-driven approach. Simply speaking, after gathering the data, we seek to steer the brain dynamics to a non-seizure state, which will then be used to determine a specific sequence of discharges. This approach implicitly accounts for the response and, as a consequence, for gender, age, and location. Furthermore, it does not require a change in the hardware of the neurostimulator, but rather in the software that comprises the decision-making on how the discharges are deployed into the brain. Now, let us take a quick look into how to compute the sequence of discharges. Specifically, when an event takes place, the data gathered preceding that event is considered to assess the dynamics and the potential response to a discharge over a future time horizon. During this period, we seek to minimize the interactions with the brain, that is, the electrical discharges. Furthermore, this has to be done taking in consideration that we should attain a non-epileptic state, as well as under the implicit restriction of the dynamics and the response. At last, but not at least, we should explicitly account for the actuator and sensor constraints to satisfy manufacturer constraints as well as medical standards. As time evolves, we need to reassess the previous strategies through the predicted and observed response to increase the efficiency of the discharges in mitigating the seizure. Closed-loop neurostimulation devices will enable John to have a relatively normal life, as well as many other individuals who have or will have neurostimulation devices. These individuals can also count on personalized, real-time, closed-loop robust neurostimulators.